So this is another video on area and volume. It's going to be another problem question. This one will also be quite long, just because these questions are generally quite long and tedious. That's why the videos are a little bit longer. So anyway, I'm just going to jump straight into this one. There used to be a wooden block, so a big perfect wooden block. Then a perfect quarter of a circle was removed from it. Okay, so this curve here should represent a quarter of a circle. So obviously the diagram doesn't show it, but just pretend that it's a perfect quarter of a circle. So it's asking us for the volume of what's remaining and the surface area of what's remaining. So how are we going to do this? We're going to break it up into little separate bits. So the first thing I'm going to do is I'm going to look at the volume. So part one, the volume. So the method I'm going to do to try and get the volume is to find the area of the face. So I'm going to say area of the face and then multiply it by the depth. Okay, so that is the same method we're going to use if we have a prism. Yeah, so that's the area of a prism. You get the area of the face and you multiply it by the depth. So to get the area of this face here, the front face, which I'm kind of shading in here in the red, I'm just going to draw a picture of a square. So it originally would have looked like a square here, and this will be 20 and this will be 18. Again, this clearly isn't to scale. And then also there's going to be the semicircle taken out of it, or the quarter of a circle taken out of it. So this time it's going to look something like that, and that this is going to be 2 centimeters as well. All right, so to get the area of the red rectangle, it's just going to be, so I'm going to say that the area, if my pen will work, so there, hopefully I fixed it there. The area is going to be the width by the length, which is just going to be 18 multiplied by 20. If you multiply 18 by 20, you'll get 360 centimeters squared. 360 centimeters squared. And now we need to find the area that was taken out by this blue here. So if I color in this area here, so this is the area that's missing. Then I can find the remaining area, so this red area, what's left, and this is what we're looking for. Okay, so how am I going to get this blue area here? We have a perfect semicircle. So again, ignore that. Actually, I'm going to do that one again. It's just too bad. There's a little bit better, still not great. So we need to find the area of this quarter of a circle. So the formula for that area is going to be, it's going to be 1/4 multiplied by pi r squared. So pi r squared is the area of an entire circle. So then 1/4 of that area is going to be the area of a quarter circle. So we need to find we need to find the radius. So in this case, we can see the radius, since it goes the whole way from this side to this side, is going to be 18. And then here, we can see that it's going to be 18 as well, because it's going to be 18 plus 2, and that's 20. All right. So that means the area is going to be, and I'll go into green for that. Area is equal to 1/4 by pi by 18 squared. Stick that in your calculator and you're going to get 81 pi centimeters squared. 81 pi centimeters squared. So that means to get the remaining red area, so I'll do this in white. So I'm just going to say remaining area. It's going to be 360, which is the entire area, minus the area was taken away from the circle, which is this blue area, minus 81 pi, and then that as a decimal point is going to be 105.53. 105.53 centimeters squared. So that's the area of this little red area here. So that's the area of that, of the face. And then remember we said that to get the volume of this shape, we're going to get the area of the face and multiplied by the depth. So the depth is going to be 4 centimeters. So that means if we're going to find our final answer, so I'm going to say that the volume again is going to be equal to the area times the depth, and that's going to be equal to 105.53 multiplied by 4, and that'll give us 422, so 422.12 centimeters cubed. So that is the volume of that shape. Okay, so that's the first part done, that's the volume done, and now we're going to look at the surface area, SA, the surface area. So I'm actually just going to put a little bit of a box around that, and now we're going to look at SA, the surface area. So I got a quick copy here of our drawing from above. So if we want to find the surface area of this shape here, we have to find the area of each individual face, okay? So for that, I'm going to number them, so I'm going to call this 1, 2, 3, so I'm going to have 4 on the top, okay, so that's one we can't see on the top. We're going to have 5 is one we can't see at the back here, and there's going to be one more, it's going to be 6, and that's going to be it's going to be the same as number 1, it's just going to be on the other side of this. Okay, so we have 1, 2, 3, 4, 5, 6 different shapes to calculate. So 1 and 6, easy enough, we've already done it. So if we scroll back up, we can find that the remaining area, or the area of our face, is 105.53 centimeters. So I'm going to say 1 and 6 is equal to 105.53 centimeters squared. 1 and 5 and also 4, 5 and 3 are going to be easy enough to calculate as well. So I'm going to say 3 here. Do it in red. Ooh, I'll redo that because that was awful. 3 in red is going to be 4 centimeters deep and 2 centimeters high, because we can see that this is 18, this is 20, so that means the area or the distance from here to here is also 18, because that has to be the radius of the circle. Yeah, so that's 18. That means that has to be 18, and this little bit is 2. So this little rectangle here, which I've crudely drawn, is 4 by 2 centimeters. So again, just to simplify, 4 by 2 is going to be 8 centimeters squared. Now we're going to look at part 4. We'll go green. That's going to be 18 by 4. So it's 18 multiplied by 4. And 18 by 4 will give us 72 centimeters squared. 72 centimeters squared. And then one more, we have 5 is going to be 20 by 4. So here we have 20 by 4. And this will give us 80 centimeters squared. So now we almost have all of the surface area calculated. It's just 2 is the final surface area we need to calculate, which is also the hardest one. So I'll scroll down and make a little bit of space. And just quickly to clarify, if you guys weren't clear on all of this, so 1, 6 we already calculated, 3, 4 and 5, they're all rectangles, so it's just the width by the length we were calculating. So if you looked at this from the top, you'd see a rectangle. Look at this from the side, you'd see a rectangle, and that's what we're doing there to calculate the areas. So anyway, number 2 now, okay, so I'll write this here. 2, as we can see here, it's going to be curved. We have this shape here. But one other thing we can also see is that it's actually a rectangle, okay? So this is actually a rectangle, it's just curved. Rectangle, and I'm just going to say that it's also curved. So we need to find one length, which is this side here and this side here, and we already know that. That's going to be 4 centimeters, that's the depth. So really what we need to do is we need to find this length here, the other length, okay? So again, I'm going to start by drawing out our semicircle. And we know that this is 18 centimeters and 18 centimeters, that's the radius. So if we're going to find the perimeter of a quarter of a circle, so I'll say perimeter of a quarter, I'm just going to draw a picture of a circle because I'm too lazy. That's going to be equal to 1/4 multiplied by the perimeter of a whole circle, which is 2 pi r, which overall is going to be pi r over 2. So our specific perimeter here, which is this distance here in the pink purple we want to get, is going to be equal to 18 is the radius, so it's going to be pi multiplied by 18 divided by 2, which is just going to be 9 pi centimeters. So that means if we want to find, round the space, the area of number 2 here, it's going to be 4 multiplied by 9 pi. So I'm just going to write that here in purple. This area is going to be 9 pi multiplied by 4, and that's just going to be 36 pi centimeters squared. So if we want to add all of these up, we can find our total surface area. So I'm just going to scroll over a little bit and I'll finish that up. So to add them all up and get the surface area, I'm just going to say the area is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6. So that's, again, just let the examiner know exactly what you're doing. And it's really nice just to label each side and to lay it out like this. Just makes it a lot easier for you at the end. Add them all together into your calculator. You're going to find that the total surface area is 484. So I'm just going to write that again. That's a little bit untidy. 484.16 centimeters squared, and that's our final answer. That's the surface area of that shape. So hopefully you guys got that. So that's it for area and volume problems. So again, it's just about practicing and practicing loads of different problems. breaking it up. So watch these videos to kind of get the general method how to approach the problems, but then it's totally up to yourself to practice and practice and practice. So again, if you like the videos, like and subscribe. In the next video we're going to look at the trapezoidal rule, and that's going to be our last bit of area and volume. So we'll see you in the next video. I hope you enjoyed this one, and don't forget to like and subscribe and tell your friends.